All right. Does anyone want to volunteer an answer?
Austin, volunteer.
We have Austin. We have all the
We're representing. We're outnumbering you people.
I only count one Asian.
Technically.
Hey, buddy. What's your name?
You get the answer. I know.
Me. I didn't even remember the F word in the captain.
Okay.
Justin.
Justin.
Isn't it music? Justin.
Kevin, what are you saying?
I got that step, but I don't know where to go. Oh, that's the answer.
I get it. And now she's gonna fail at physics.
Is it wrong?
Three.
Kevin, show us what you got.
Yeah, is that the answer?
What's up?
Okay.
We'll find out after.
You gotta like crop out all the voices except for him. I mean, I'm not sure if what I said
Again.
half hour is insane.
Back to me.
So far it's been a half hour.
Back to me. That's it. That's it. Integrals, derivatives, not that hard. Relative to what we have to do in this class, right? So let me just go through an explanation and then I'll take questions. So we look at our formula sheet, okay? We have A and we're trying to find B. So we know we're trying to find an integral again. So we look down, it's going to be the last integral where it says sine. So the one on the formula sheet says integral sine ax inside parentheses dx is equal to -1 over a cosine a of x. Now, for us, in our purposes, a is just simply a constant. T is the variable of which we're taking the integral. So this 2 pi capital T on the inside, that's our a. Okay? That comes out here, and we flip it, because it's 1 over a. Then you're just simply following the formula, cosine AT. It remains on the inside. Haley? Because that's the variable of which you're taking the integral over. So, Haley, if you look at the formula here, you have AX on the inside, only A comes out.
Oh, it's so instead of dx is dt.
Yes. Yes. T is the X. Cooper?
So big T is a constant, right?
Yeah.
Because
For
it's a period.
I was saying it. Big T is a constant. I didn't write it down. But
No, yeah, I think so.
yeah. So it's a constant for this purpose.
Does dx just mean that you're finding it as a variable of x?
You're fine. Yeah. You're taking the integral with respect to X. It's an operator. It's not a variable.
So this one's less complicated because V is not in the original equation.
Correct.
Negative
Just like ln of X
3t sine.
is not itself a complicated formula. It's just 1 over X, right? It just becomes a little bit more complicated when you have to start flipping stuff around, and you have that 0 term. So when we plugged in 0, we still had a term left over.
I saw.
Jason,
When you take the derivative of that, it doesn't come out. It's okay.
Yeah, it does. Okay, so when I take the derivative of this,
T over 2 pi or just
when I take the derivative of this, just to check to make sure I did the integral correctly.
Yeah, it's Jason. It checks out.
So 2 pi over t comes out, and it's negative, because this is our a term. So if I'm going to take the derivative of velocity, I get 2 pi over t,
Because it becomes a negative sign.
and then it's negative sine
that's chain
2 pi t
chain rule, right? You have to chain
over
rule.
t, and I still have my leftover
Maybe you
negative
can just whip
3,
roll it.
so negative 3
But I probably won't get the right answer.
t over 2 pi, so negative cancels, 2 pi cancels, t cancels, and I'm left with 3 sine 2 pi t over capital T. My original equation.
Wait, I don't remember learning that when we take the
Oh, so you
derivative
took the
of
derivative
sine
of the velocity to get back to the.
Yeah.
I always.
Oh, okay.
Oh, I thought we weren't allowed to touch it.
function. Yeah, we weren't allowed to touch
Yeah.
it. Wait, so when you take the derivative of trigonometric function,
Say that again?
when you take the derivative of trigonometric function, you do the chain rule of what's inside the trigonometric function. It's the negative inverse of that value. Like when you take the derivative, like the 2 pi t
So
over
the
t,
negative. Okay.
because you
Guys.
take the 1 over negative a.
Yeah. For the purposes of the trig functions, when you take the derivative of sine, it's positive. When you take the derivative of cosine, it becomes negative.
Right.
Okay? So the opposite is true. When you take the integral of sine,
Uh-huh.
it's negative.
Uh-huh.
And when you take the integral of cosine, it's positive.
Okay.
So the reason why, and it's laid out here on the formula sheet. So you don't have to memorize
Oh,
that.
okay. Yeah, I think it's just because the main reason why we have this is that it cancels out.
Because when you look at a sine function,
Yeah, but like originally when like
sine
if it's
function
sine,
starts off
whatever, inside the parentheses, we're not gonna touch that. I know.
like that.
Yeah.
And then a cosine function is just shifted over 90 degrees.
Right.
So that way the peaks and valleys match up with the values. So this starts off at a high value when the slope here is the greatest.
Yeah.
And then this is 0, so that's when this is 0. So it's shifted over 90 degrees. Okay. Any other questions, guys?
Can we look at the multiple choice again? Just so I can see the wording.
I was paraphrasing it for a little bit
Oh,
because I didn't copy down exactly everything.
okay.
But I can read it to you, and then you can compare it to how I read it up here. So an object is released from rest at time t equals 0 and falls through the air, which exerts a resistive force such that the acceleration a of the object is given by a equals g minus bv, where v is the object's speed and b is a constant. If limiting cases for large and small values of t are considered, which of the following is a possible expression for the speed of an object as an explicit function of time?
It's supposed to be the same.
Haley, and then Cooper.
Oh, okay. So basically, in this problem, it's always going to be a natural log part.
Because it has v already in there, and that's what you're trying to
So
find.
when we see a equals g minus bv, then we know it's going to be the log one, I mean the natural log one.
Because you're dealing with drag, you know that it's going to be a natural log.
Oh, I see.
Cooper?
Great, so I'm just not quite sure how you like determine like in this equation like that one, like which is a and which is x, because like I know that a is the constant,
Yes.
right?
Yes.
And so I think here b is the constant
And g is also a
because
constant.
gravity.
Right. V is our x, because that's the variable.
Right.
X is a stand-in in math for anything that you're changing.
So like what, so like with the
We are
equation
allowed
it should
to
be
take
natural
the
log
derivative
is
in
x
Okay.
is a natural log of g
No, because
minus
it's still a
b
variable.
plus
It's still
b,
attached to a
but
variable.
that's not what
He said they're
Well,
constants.
It's
but this isn't a constant. 2 pi
a plus
2 pi over
x,
t is
but
a
x
constant
has an extra
multiplied
constant.
against t. When a constant is multiplied against t, it's still
So it's really it's a minus b.
So it'll be 2 pi over t.
If I was going, it's more complicated than what's on the back of
Yeah,
the
it'd be 2
formula.
pi over t.
We never changed
Slightly more
Yeah, we do.
complicated.
I think we do change.
Yeah,
I
just
think we
the
just
v.
forgot. Because when you take this,
So
2
v
pi over
is
t
v is the
multiplied,
variable
that
at
would
which you're taking
cancel,
the
it's going to
integral or
become
derivative
3
of.
sine.
If you do cosine,
I get that.
Do you do that every single time? Because it's not in the
t, and you take the derivative
like the equation sheets. Like, does that mean you do that every
2
single time?
pi t, t over t.
In this case, multiply times 2 1 over t.
No, like get rid of the b.
Multiply times 2 pi
Oh,
over
we
t.
did do that.
Yeah. So that's why we have to do this.
So
Because
it's-
it cancels.
Negative 2 pi over t.
Any other questions, guys? Because I got nothing else.
That's still not. Yeah, it is because then it's negative 2 pi over t, and then it'll be.
That's why when we found the antiderivative, it has to look like this. Because
Well,
then it
okay,
cancels out to
so
make the 3 sine.
there's obviously this portion of it And off the top of my head, I would say it's at most 5 points out of 50. But every individual part of doing that integral gets you points. So even if you miss something, you'll probably get most of the points.
Is it just gonna be one problem? One.
Yeah, it's going to be, well, depending on what period you are, there's 2 problems for one and 1 problem for another.
Are they easy?
They'll be equal in difficulty.
What about the makeup?
Right now, I'm keeping it at 2, so hopefully there's no makeup. If there's more people tacked on,
Oh.
right? That was the problem last time. I had like 6 people, so I had to do a makeup. So no other makeups. Otherwise, I'll have to find a harder one.
Should do it just for Kevin.
He basically felt that way last time.
No, I
That's
thought it
his
was
fault.
Okay, so what I'm going to do is I'm going to post these notes on my website or on Classroom, and then when Dustin edits the video tonight, right?
Yep.
Because you have a night off.
Yeah, I got it.
All right.
I think your
Dustin
voice
edits
cracked
the
a
video.
little.
I'll post it up.
Your voice
as
cracked just a
alongside.
little.
Okay, so can I end it now?
Thank you guys.
Hey, bye.